Hi, my name is Taylor Heim and I'm a data scientist at SAS Institute's Federal Division in Washington, D.C. In the next several minutes, I'd like to talk to you about what a data scientist is and how I help various organizations very quickly realize the inherent value of the operational and administrative data that they are working with to achieve their mission. This is what every single worker in the information age faces. How do I take all the data that's coming at me and make sense of it? That is to say, given the ever-increasing data volumes and variety of sources a person is expected to search to make evidence-based decisions in a timely manner, it's getting exponentially more and more difficult to do so. What's needed is a relevance engine, a machine that will sort through incoming information and assist the end user with statistical determination of whether or not the new information is relevant and should even be considered in the subsequent decision making. I'd like to focus on a specific application that I've built with other engineers here at SAS that we think is extensible across numerous industries. We call it adaptive case management. For this demonstration, we're using Appian's Business Process Management Suite, which is a market-leading HTML5 application that allows you to construct dynamic workflows and provides various integration points to modern computing platforms. In short, it's a very flexible framework with which to create, deploy, and maintain detailed case workflows that can dynamically incorporate statistically driven informational inputs and recommendations to end users in meaningful ways. I'd also like to point out that this demonstration utilizes both a traditional Oracle transactional RDBMS as well as a more modern Cloudera Hadoop infrastructure for both in-memory and in-database scoring, which allows us near real-time delivery of a wider variety of statistical queries that a user can access from either a web or mobile application. That said, let's launch into the demo. We're using CDC data, and this is their Vaccine Adverse Event Reporting System, or VAERS. The reason I'm using this is it's publicly available, and we really need to run those analytic routines on enough observations to obtain statistical inference and provide relevance to the end user. So without further ado, let's actually just launch right into the demo. This is SAS Enterprise Miner. As you can see, it's our predictive modeling toolbench. So I'm going to walk through how we're going to create some of the predictive models and text mining algorithms that interact with the investigator through the case management applications. And again, in this case, we're using the CDC data, which is vaccine adverse event reaction data. We're going to actually just open that data up right now and take a look at what it is. You can see we're looking for the serious event. That's the target variable. And then we have other data elements around, just case detail around what people have entered into the web form, is what their symptoms are, what type of vaccine they received, etc. So here what I'm doing is just exploring some of the text mining capabilities and looking at concept links associated with the word vomit. It looks like it's actually a much higher weight than some of the other text terms that are in my list here. And I want to associate that with the serious outcome. So you saw that 29 out of the 29 cases of vasodilation associated and vomiting is associated with a serious case. So the presence of that term in any of my text will increase the risk score and chances that I should be focusing on that case as an investigator. So that's all automated decisions that I'm going to suggest to the investigator an increased risk that, yes, maybe you want to check this person out when we get to the case management application. So the next component of our prototype is the concept of triage. So the investor's day being organized by rank order in terms of risk, questions that they need to nail down. So in this case, in the CDC example that we built out the prototype on, we're looking for if something was a serious reaction based on the data that the person is uploading to their form. This is a cumulative lift chart. This just tells me that if there's a theoretical prevalence rate of 10% for adverse event reactions, randomly sampling the population would only give me one serious case out of the 10 I had to interview as a CDC investigator. If we use the SAS algorithm we just produced, we would find 7 or 8 serious cases out of that same sample of 10, thus reducing the number of false positives and getting the attention of the CDC investigator on the serious cases that they need to follow up on. Now that we've talked about how to create algorithms that assist the investigator with assessing the risk of their underlying cases, we wanted to touch very briefly on the integration points with the case management system and the analytics system that is deriving those estimates. The first step, as you can see, is triage, and we do this by deploying the SAS algorithms in the Oracle database itself so that Appian can then read those triage scores and raw case data into the case management system so that we can develop a process flow around that work stream. So as the next integration point is, as the investigator enters additional data and wants it reevaluated for risk, a service call from Appian to the SAS architecture dynamically rescores that individual record and puts that information back in the Appian interface so that they can continue working with that case and the additional information that they have on the increased risk. Now I'd like to walk you through the investigator user interface. This walkthrough is based upon the process model that we created to meet investigator requirements, giving them more serious cases to follow up on in an easy-to-use interface. So the first thing is I'm going to go through my triage list of CDC cases that SAS has provided me based upon a scoring of their inherent risk. And I'm just going to go to 50 and 75% risk and go into this case ID. So here I can see it's a pneumonia vaccine. The risk score is 70%, so this is a fairly likely case. The information, around a 67-year-old white male. Patient developed swelling in the red arm from elbow to neck and chest area, red rash, and he was placed on some drug regimen. So I might want to follow up with this. So I can just hit related actions and create a CDC case out of that and start following up on the process within the case management process flow. So I can see I've got that case ready to update. Here I can submit additional symptoms. So again, the ability for the case investigator to add additional data to the case. Here I can say maybe in the follow-up I learned that the patient was admitted to the inpatient floor with violent vomiting, which we know from the previous word strings is a pretty significant variable and would raise the or increase the risk score of this particular case, but we are going to submit it for a rescore, which makes that call back to SAS where it goes through that text mining algorithm that we've developed. And then again, I should see it here in the elevated cases, and there's my case. Again, went from a 70 to an 80% probability of being a serious event, and there's the additional symptoms that I've discovered as a case investigator, again going to that next phase in the process based on the information that the investigator's entering. Now that we've had a detailed look at the CDC use case of statistical detection of risk using both structured and free-form text from patient complaint surveys and CDC investigator entries, we can extend those same techniques to other applications. This is dummy data provided to us by the Office of Personnel Management, which is fairly evident given some of the names that they've attached to the data. Today we'll be looking at Marcia Brady and simulating real-time data feeds from United Airlines and using natural language processing, or NLP techniques, to synthesize relevant alerts for the continuous monitoring and evaluation of clearance holders working for the U.S. government. Again, these same techniques provide OPM with a wealth of relevant information and the unique opportunity to be alerted to only that relevant information that they need to gather additional data points around so that they can categorize risk in that specific dimension. We will start out by creating a simulated transactional data feed from United Airlines. This is a trip that Marcia takes to a foreign country and doesn't report to her designated OPM security officer. As you can see, Marcia's entry is still normal. It's still a score of 27% that doesn't cause a false positive. And oh look, it's a trip to Toronto to visit our friendly neighbors to the north. Again, we're simulating a suggested OPM investigator process flow that doesn't automatically alert and generate a false positive, given it's just a trip to Canada and it's just the one time. But watch what happens when we simulate another data feed from United Airlines around a second trip. Already you see the alert on Marcia, and drilling into her records, the fact that there were 2 unreported trips within a 30-day period was enough to elevate the risk and trigger the alert. Again, it's to Canada, so maybe this is just a phone call to Marcia to let her know that she has to report to her security officer before leaving the country again. At this point, I can assign that action to her security officer to reach out to Marcia and obtain more information. And then, switching to the investigator's perspective, they can upload additional relevant information. In this case, there was a sickness and subsequent death in Marcia's family. During the call, Marcia forwarded the investigator an email with a PDF attachment of her grandmother's death certificate her parents provided her just in case anyone needed it for emergency travel reasons. So given the key terms and additional assurances from the presence of a death certificate and the free-form text description of the situation, the risk has been subsequently lowered below the alert level. Finally, the security officer superior can go into the system and review the risk and initial alert around the individual, in addition to the information that the security officer diligently captured to explain and mitigate that risk. In this case, we're going to clear Marcia for duty. This is our new reality. In a world where we have an overload of data from sensors, mobile phones, monetary transactions, it's just too much for one person alone to synthesize the correct information they will need to accomplish their task. Pretty soon, you won't even need to know when your child wets themselves. Did you know that you can actually buy diapers from Huggies that tweet your phone when they become wet? It sounds crazy, but if I can establish better sleep and accident avoidance patterns to better train my toddler, wouldn't that be worth it? In that respect, we need to build better case processing and investigation systems and do it more intelligently. That means cheap, reliable, and scalable Hadoop platforms like Cloudera. These are the next generation of workhorses that can store the data on the same node where the compute is executed. That allows application developers and data scientists like me to deploy advanced analytics we've developed in SaaS into case management systems, as well as other systems throughout the organization in near real time. And to that end, I'm not interested in just sitting in a bubble. I want to hear from you, Internet. What did you think of the application? If you could have a killer app that made your work easier, what would that look like? I'd like to know, so leave your comments or feel free to respond with your own video questions. Thanks for watching, and you can follow me on LinkedIn or Twitter. My information is in the links below.